The part I have highlighted yellow is OriC, or the origin of replication. This is where replication begins. In this next drawing, the pink arrow signifies something that goes from 3' to 5'. This is the leading strand. And this is where replication takes place continuously. On this other piece of DNA is where the lagging strand is. This lagging strand goes from 3' to 5' and is where replication takes place discontinuously. In my next drawing, you will see a replication fork. Here in yellow, I am highlighting Gyrase. The Gyrase reduces torsional strain and relieves supercoiling. In green, I am drawing primase. Primase synthesizes short RNA primers to allow DNA synthesis to begin. In red, I am drawing helicase. Helicase breaks hydrogen bonds that hold the two DNA strands together. Next, I am highlighting again the lagging strand. Here in this lagging strand, it breaks into little fragments called Okazaki fragments. These are the short lengths of DNA produced by discontinuous replication of the lagging strand. They go from 5' to 3'. Next, in pink, I am drawing the leading strand, which goes from 5' to 3'. I previously said that the leading strand is where replication takes place continuously. This is one method of drawing the replication fork, and next I will show you my other method. Again, in green is Gyrase. Gyrase reduces the torsional strain. Next, I will be highlighting the primase-helicase complex, which I did in the previous drawing. These work together to synthesize RNA primers and hold the two DNA strands together. Next, these purple little dots are called single-strand binding proteins. These binding proteins help maintain the DNA by protecting, stabilizing, and preventing hairpins. Next, I have highlighted in blue DNA polymerase 3. DNA polymerase 3 synthesizes DNA and attaches to the primer to add nucleotides. This addition of nucleotides allows for phosphodiester bonds to form. These bonds are what makes up the backbone of DNA. Next, I will draw DNA polymerase 1. However, I have extended the strand of DNA, so pretend where I have drawn polymerase 1 is the same place where polymerase 3 took place. DNA polymerase 1 removes the RNA primer and uses 5' to 3' polymerase activity to replace the RNA with DNA. Lastly, drawn in green, ligase seals the nick between DNA added by the two polymerases without adding another nucleotide.